Okay, so today we're just going to look at factorising, which put simply is putting something into brackets. It's the opposite of expanding, which is a process we already know about. And specifically today we're going to look at factorising quadratics. Now the general format of a quadratic is ax squared, a being the coefficient of ax squared, plus bx plus c. That's the general format. We should be pretty familiar with what that looks like. Obviously the signs can vary, but generally we're expecting an x squared term, an x term and a numerical term. Obviously any one of those could be 0, might not appear, but that's our general format. So in terms of factorising, we'll get straight off onto it. The easiest quadratics to factorise are ones where the coefficient of the x squared term, for example the a term here, is equal to 1. So I've got 3 examples which I'm just going to quickly show you. Which we'll talk through. So the way in which I'm sort of looking at this, the key thing is this second sign, okay? So the plus, plus, minus in this column. Now, if it is a plus, what I'm saying to myself here is I am looking for factors of 20, and here's the key bit, which add up to give 9. Okay, so factors of 20 which add up to give 9. Clearly I'm thinking about 4 and 5. So in terms of my answer, I already know that my brackets are going to look like this. Now I'll come back to the other stuff in a minute. For the next one, same thing. I'm looking for factors of 4 which add up to give minus 5. Now what I'm thinking there, factors of positive 4 which add up to give minus 5. Yeah, it's minus 4 and minus 1, isn't it? So I will put the signs into this one, but we're going to talk about signs a little bit more in a minute. Just quickly for that top one, I'll go back and finish that one now. Factors of 20 which add up to give 9, well, they have to be, don't they, positive and positive. For the next one, I'm looking for factors of 60. And now this one's a little bit different in terms of what I say to myself. Because this is a minus, I'm saying factors of 60 with a difference of 7. Okay, factors of 60 with a difference of 7. And so those which I'm looking for, I think here, are 12 and 5. Now, this one's interesting, okay, and we're going to talk about this a little bit more. I know that this is x12 and x5, like we just explained. Now, I want to talk about sign configuration. If this is positive here, both of these signs have to be the same. Okay, you can see this here. There's a plus plus example and a minus minus example. If it's a negative for this last sign, it's going to be one of each. Okay, and so it becomes a little bit harder, ever so slightly. If it is one of each, we need to think about which one is which. Now, looking at my second term here, I want to end up with minus 7x. Okay, and so just very straightforwardly, I need the 12 to be negative and the 5 to be positive. Okay, so just what I'd like us to think about, that's our easiest quadratics which we can factorise. We need to think that sign configuration is key, and that's a message which will help you in all of the quadratics you're going to factorise. Just a quick message also, you should always get factorising quadratics right, because if you expand these brackets, you should end up with the one which you just started with, okay? So, moving on. Level 2 quadratics, difference of two squares. Now these ones are a little bit funky because, as you can see, the general format, ax squared plus bx plus c, isn't really in existence here because the bx term isn't there. Well, what we're expecting, it has to be a minus for difference of two squares, difference is a minus, is we're expecting two square things. So obviously x squared is square and 9 we know is a square number. Second example, 49 is a square number, and 4x squared, well, yeah, that's 2x times 2x, isn't it? Okay, so that is also square. These factorise in the following manner. X squared plus minus 9 will factorise to x plus 3 and x minus 3. And the second one will factorise to 2x plus 7 and 2x minus 7. Now, the way in which these work, these difference of two squares, is that if we imagine expanding those brackets, I use FOIL to expand double brackets, the O and the I term cancel each other out. Yeah, you get x squared, and you get the minus 9, but for the outers you get minus 3x, and for the inners you get plus 3x, so that cancels each other out. So there's our first two levels of quadratics, hopefully nice and straightforward so far. We're going to move on to have a little look at some slightly harder ones, and I would say they're going to be slightly harder when our x squared coefficient isn't equal to 1. So let's start off with this first one, 2x squared plus 7x plus 3. The way in which I'd like us to tackle this, and just before we start, I'm going to consider the sign configuration. Because this is plus plus, we should already understand that my answer here is going to be plus plus. This one here, because it's plus minus, is going to be one of each. Okay, so we should already have an understanding, roughly, of what our answer is going to look like. But the way in which I want to tackle this is, because this is no longer 1, I want us to think of factors which are 2 times 3, so factors of 6, which add up to give 7, and then because it's a plus, it's add up to give 7. For factors of 6, add up to give 7. Clearly there, I'm talking about 6 and 1. Now, what I want us to do is I want us to rewrite this quadratic with the first and the last term, so 2x squared and a plus 3. And I want us to rewrite this quadratic with the middle term written differently. So I know that I can write plus 7x as plus 6x plus 1x. Okay, I've not changed anything there. How about that's fine. What we need to do is we need to try and link those numbers to one of the others. So I don't know if you can sort of see this or not. It probably takes a little bit of practice to get the hang of it. But 2 into 3 is like 3 times, and 1 into 3 is like 3 times. I've sort of got the same pattern going on there. Because what our next step is, we've not changed anything, we've literally just rewritten it, is we're going to factorise each half individually. For this half over here, I can take out of this a single bracket factorisation, 2x. And I'd need to times that, wouldn't I, by x and a plus 3. Same thing over here. What can I take out? Well, bizarrely, all I can take out here is a 1, actually, isn't it? I'd have to times that by x, and I'd have to times that by plus 3. Now, a little spoiler alert, these brackets always need to be the same. Okay, so I was expecting, once I had x plus 3 here, I was expecting to be able to take out x plus 3 over this side as well. Because my final factorised answer is the result from that one above. The x plus 3 forms one of my brackets, and whatever was outside the brackets forms the other bracket, 2x plus 1. Just check it's worked. Like I said, we can always check. 2x squared plus 6x plus 1x is plus 7x plus 3. Jobs are good and we're good to go. Right, next one, a little bit harder because our coefficient here, not only is it not 1, but it's also not prime, so there's several different options here. But again, same method, we're looking for factors of 90, okay, 6 times 15. And because this is a minus, we're looking for them to have a difference of 1 as opposed to being add up to give 7. Difference of 1. So factors of 90 of difference of 1, we should be thinking of, shouldn't we, 9 and 10. Now, let's think about rewriting this. So we put in our 6x squared and we put in our minus 15. We need to rewrite plus 1x using 10 and 9. Now, again, we also need to link the 9 and the 10 to the 6 and the 15. So I think the best way for us to do that, and it will take a little bit of practice, like I said, is for us to write it something like that. Link the 9 with the 6 and the 10 with the 15. I don't know if you can see that ratio of 2 to 3 going on there. Now, just double check this as well. Minus 9x plus 10x, yeah, that is still just plus 1x. So factorising this first half, we can take out 3x, and we need to times that by 2x minus 3. As soon as I've got that, I'm expecting 2x minus 3 over here, so let's just hope that we get that. What can I take out? Well, yeah, I can take out a plus 5, can't I? Just check that works. Yeah, we're fine. And so my final answer here is 3x plus 5 and 2x minus 3. Okay, so those are quite tough quadratics which we're factorising there, and we're having good success. Now, just moving on to this final example. Same drill, we're looking for factors here of 4, okay, and we're looking for them to add up to minus 6, really, aren't we? Now, just thinking about that, factors of 4 doesn't have many factors, it's 1 and 4 or 2 and 2. It's not going to be possible for them to add to minus 6. So I just wanted to finish this video with the message that not every quadratic is going to factorise, okay? And so we should hopefully have some good success factorising, but ultimately there are going to be some quadratics which we can't factorise. Now, final point is all of these things which we've done as examples, I hope you understand these are expressions, they don't have an equal sign, and so this is how we're going to leave our answer. If a question just says factorise, this is our final answer. Just very quickly, I'll use the same example from example 1. If it had said solve 2x squared plus 7x plus 3 equals 0, so now this is no longer an expression, this is an equation here, it's got an equal sign in. We would do our factorising job, I'm going to skip that step if that's okay, and we'd get to here, still equal to 0, and we wouldn't quite be done, because one of the reasons why we want to factorise is to work out the x-intercepts of various different functions where it crosses over the x-axis. And so our solutions here, I think we kind of already know this one, we equate each individual bracket to 0 if you're struggling. So x plus 3 equals 0 in our head, we get x equals minus 3. Some people just like to flip the sign, which is a little bit of a trick if you get the hang of it. This one here, 2x plus 1 equals 0 in our head, minus 1 divided by 2, we would get, wouldn't we, x equals minus a half. Okay, so just wanted to spell out the difference between factorising and solving. Just be a little bit careful of the wording of our question. But that is how we're going to factorise various quadratics. Thanks for watching.